We're now on example 2 of section 6.8 on exponential growth and decay models. A population of mice increases according to the law of uninhibited growth. If there are 3 mice initially and there are 18 mice after 2 months, what is the size of the population after 4 months? Well, we can't answer the question until we've used this information, 3 mice initially, 18 after 2 months, to find K. We don't have the growth rate, so we'll have to find that first. So step 1 will be to find the growth rate. How will we do that? Well, we know that n sub 0 initially is 3, and when t is 2, we have 18. Okay? We also know when t is 2, the equation would be n sub 0 times e to the k times 2, right? Or n of 2 would equal 3 times e to the k times 2, but we know what n of 2 is. It's 18. And I'm going to put 2k. So there's our simple exponential equation to solve for k. First, isolate the exponential, divide both sides by 3, and then solve for k. So 2k equals the natural log of 6, so k equals the natural log of 6 divided by 2. Now, I do not want to calculate that and then round to some decimal. I need to use an exact number because I'm not through. I'm using k in a calculation, so I don't want k to be an approximation. So part 2, the question was after 4 months. So now I need to find n of 4. So n of 4 will equal the initial amount times e to the k times t. Well, what's k? ln 6 over 2. What's t? T is 4. So now it's just a calculator problem, right? So now I do need to find out what this is and raise e to that number and then multiply by 3. And when you do that, you get 3.36. I'm sorry, not 3.36. 3 times 36. Sorry, 3 times. So this, the natural log of 6 divided by 2 times 4, which would actually be, the 2 goes into the 4 2 times, so you could say 2 natural log of 6. So e times 2 to the natural log of 6 is 36. And you know, you really don't have to do that on a calculator. Let's write that out just to see what happens. E, so 2 goes into 4, so that'd be 2 to the natural log of 6, which is e to the natural log of 6 squared, right? Now, remember e to the log base e? What did that end up being? This is one of our properties. That would just be 6 squared, or 36. So you don't even need a calculator to do that. All right, and 3 times 36 is 108, and we're talking about mice. So if you start with 3 mice, and this is the growth rate, that by 2 months you have 18, that gives us a growth rate, then in 4 months you would have 108. How long until there are 90,000 mice? So in other words, n of t equals 90,000 when t is what number? How many months is it to get to 90,000? All right, so we got to 90,000. We started with 3. We know k hasn't changed. It's the same problem. So k is the natural log of 6 over 2. And t is the question. When does this happen? Okay, divide both sides by 3. 30,000 equals e to the natural log of 6 over 2t. Okay, change it to a log. Here's our power, our exponent. Natural log of 6 over 2t equals log base e of 30,000. So t equals, I'm going to multiply by the reciprocal, 2 over the natural log of 2 times the natural log of 30,000. And I don't really need to simplify all this. I can just multiply and get to a result. Just use your calculator and you should get 11.5, and this was in months. So in less than a year, if you start with 3 mice you'll have 90,000 mice.